Hi there, students. Happy Friday. Guess what? Sounds like I got sub coverage. So I'm making a video here to sort of go over the do now for you. And then also, I'm going to just give you a few hints on how to do today's work and talk about it a little bit. So I asked you here to solve for the zeros, and I'm not sure how you attempted to do this. There's a few ways to think about it, but I would just try to attempt to get rid of this squared thing here. And so you could take the square root of each side, as I've shown you. Of course, the square root of x minus 17 is just x minus 17. And the square root of 0, this is the one case where the square root has only one answer. The square root of 0 is, of course, 0 because 0 times 0 is 0. So if I then add 17 to each side, I got x equals 17. And there was only one 0. Imagine for a moment the graph of this function, right? Since the way that it was written, this function here doesn't have a plus or minus on the outside, right? There's nothing out here. Then it would move 17 units to the right, and then it would open up, right? And so we can see that that vertex, which is at 17 comma 0, is the only 0. And that's what it looks like when you graph a function with only one 0. The second function, if you start by subtracting negative 4, you get negative 4 here on the left, and then x plus 9 squared on the right. Now, I know that maybe you're thinking you should divide by negative 1, but if you do that, of course, the sign of the 4 will flip, but then this thing over here becomes negative. And so then the other side is negative. And I'm not sure that that really gets us anywhere, because either way, you're going to have a negative on the left or a positive on the right, or a negative on the right and a positive on the left, and you can't square root a negative, no matter which one. And so this is the one with no zeros. And again, we should imagine what this looks like. I believe that this means it would move left. It would move to negative 9, positive 4 for the vertex, which is like about right here, but then it opens up. And we can see that that parabola is never going to hit the x-axis down here, so there are no zeros. The last one's a little tricky, I think, because you've never seen a 2x inside the parentheses before, but hopefully you were able to figure out that you can still solve this. You know how to solve this. If you subtract 81 from each side, you get a negative 81. And then on this side, it's a negative 2x minus 1 squared. And of course, we can't square root negatives, but now we could divide both sides by a negative 1. And because both sides are negative, this flips both sides to being positive. And so we have 2x minus 1 squared equals 81. Of course, now we can square root both sides to get rid of the second power. And you know the square root of 81, and it's not just 9. The square root of 81 is 9, but the square root of 81 is also negative 9. This is another one of those situations where we have to split into negative land and positive land. But you can still solve these equations. That 2 shouldn't be too confusing. Add 1 to each side. I have 10 equals 2x, and therefore x would equal 5. So one of the zeros here is x equals 5. And here I'll add 1 to each side, and then I would have negative 8 equals 2x, and therefore x would equal negative 4. So that's how we would find those two zeros. And I won't go over the graph on this one. Then on the back, I had originally planned to do more with this, but if you were able to graph these, then you're in very good shape. The vertex of f of x is at positive 4, negative 8, and then it opens up. And so hopefully your graph looks about like this. And then I'll just kind of stop there. And so there's one parabola, okay? And then the other one, I'll do in a different color. The vertex of g of x is at positive 4, positive 10, but importantly, it opens down because of the negative symbol. And so it would look about like this. You're getting very good at graphing parabolas, so I'm not going over that detail. And the two common solutions that I asked you to find are the two places that those parabolas intersect each other. And so we can see that we have one common solution at 1, 1, and the other one at 7, 1. Those are the common solutions. And I want you to know that this is enrichment. This is not going to be on a test or anything like that. I just wanted to, show you a situation where there's two parabolas that intersect. Okay, so then finally, your assignment today that whoever is in the class for me will be passing out to you is just what I would call like an omnibus. It's just a ton of review problems. So on part one, I ask you to write it in factored form. This means, of course, that you should rewrite it like this, where it's a multiplication problem between two factors, numbers that multiply to equal negative 14, but also add to equal negative 5, and then those tell you the zeros, like we've done many, many times. Now, I only have told you about this once on Wednesday, but if for all of these ones here on the left, you have to first factor out a negative symbol, like this. Remember, we divided everything by -1, and it flipped the signs? And then and only then are you going to be able to factor this. And I'm telling you this because in first period, almost nobody remembered that. So remember to do that. There is a misprint. So please, 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 as you get the assignment, this -107 was supposed to be a -117. So please change that. And this one's very challenging. I won't go over the back here, but I will say this. If you get stumped by any one problem, just go to the next problem. Don't sit there staring at one that you don't understand. I just want you to practice as much as you possibly can. And then in the last 5 minutes of class, the teacher will show you the answers under the document camera. So I really hope that you have an excellent midwinter break. I'm sorry I didn't get to see you today, but also very glad I didn't get to see you today. So have a great break. I'll see you after break. Take care of yourselves. Bye-bye.